Yes, welcome. Let's look at how to derive rate laws or rate equations when given rate limiting step. So you remember in the previous examples we looked at uh, this very reaction. You can see the reaction A going to B, and we said that for such a reaction that we can have this to be the rate mechanism. A getting adsorbed to the catalyst surface to form AX, and the A that is already on the catalyst surface transforming to form BS, then the B that is on this catalyst surface dissolving to form B plus X. So we have adsorption, surface reaction, and desorption. So this is the rate mechanism. Then looking at this rate mechanism, you can easily derive the rate equation. The rate of adsorption, RA, is equal to KA in brackets. Once you get to the bracket, look at what is inside here. You have ordinary A in the gaseous phase, which will give PA, and empty or vacant site of the catalyst, which will give CV. So we have PaCV. That's why here we have PaCV minus, you get to this other side. This other side you have A that is on the surface of the catalyst. So that's why we have concentration of AS, that is A on the surface of the catalyst, all over Ka. So that's how you derive the rate equation from the mechanism. For the second one, we have A on X already. So that's why this side you have CAS, whereas this other side you have B on X. That's why we have B CBS all over KS. That is for RS. So you have KS bracket CAS minus CBS over KS. Then for the last one, this option, we have BS this side. That's why we have RD equals to KGBS. Then minus, what do we have here? We have B, ordinary B on the gaseous phase, which will be represented by PB, and vacant site X, which will be represented by CV. That's why we have CV and PB all over KD. So that's how we derive these rate laws from these mechanisms. Now, we are told that the surface reaction, the middle one, is the rate determining step. Once you assuming that surface reaction is the rate determining step, you're going to have that RA all over this Ka is equal to 0. Also, RD all over this KD will be equal to 0, since this is the rate determining step. And that's what we have here, RA over Ka equal to RD over KD equal to 0. Now, having that means we can now equate RA over Ka equal to 0. That means everything inside this bracket is also equal to 0. So you can make KAS the subject of the formula so that it will simply go here. And this is what we have. When you make KS the subject of the formula from there, you have KAPACV. Then from this last equation, you can also, since RD over KD is equal to 0, that means everything inside here is also equal to 0. So you can make CBS the subject of the formula. And when you make CBS the subject, you have PB over CV. I mean PBCV all over KD, which is the same thing as saying KB. If you want to replace KD with KB, you will now have that 1 over KD is equal to KB, because the reciprocal of the desorption constant is the same thing as adsorption constant for B. So that's how, instead of having this PBCV over KD, we have KB PBCV. So having known what CBS and AAS is, then substitute it into this very equation, the controlling equation, which is RS equal to KS CAS minus CB over KC. So when you do that, you have that RS is equal to KS bracket CAB BACV. That's in place of CAS, we are replacing it with CA BACV minus, in place of CBS, we are replacing it with KB BBCV all over KS. So this is what we have, and we can actually extend this to this. What happened here is that we just multiply the up and down this side by Ka and Ka. So we introduce Ka here and introduce Ka here, so that we have this. Why we did this is because we want to collect Kb over Ka Ks to be equal to 1 over Kp. So when we do that, we'll have, this is what we'll have. We can separate, since we have Ks in both of, we can have Ks to be this and this to be this. So in place of all these things we had here, in place of this Kb over Ks Kb, we replace it with 1 over Kp. And that's why we have this Kp here. So we can also get out Ka because Ka is constant, Ka and Cv is the same for both of them. So we have Ks Ka Cv in bracket Pa minus Pb all over Kp. So actually what we did was that we did Kb over Ks Ka to be equal to 1 over Kp. Now we do the general vacant site balance. Total site, so total active site is equal to vacant site plus CAS plus CAB. So that's what we have here. But we already have the relations for CAS and CAB, so we'll bring them in so that we have CV plus KAPACV plus KBPBCV, which are the different values of CAS and CAB. So make CV the subject of the formula. There's CV here, there's CV here, and there's CV here. So making CV the subject of the formula, we'll get CV to be equal to CT over 1 plus KAPA plus KBPB. Now put it back in the general equation of RS. So we have RS equal to KSKA bracket PA minus PB over KP into bracket, instead of CV, we now have CT over 1 plus KAPA plus KBPB. So that finally RS will be equal to KSKACT into bracket PA minus PB over KP all over 1 plus KAPA plus KBPB. And that is the final rate law, given that RS, or the rate of surface reaction, is the rate determining step. So first thing you do is that you write the mechanism of the equation for you to determine the rate law, given the rate determining step. Write the rate, write all these, which are the rate mechanisms. Then looking at the mechanisms, rate mechanisms, looking at the reaction mechanisms, I mean to say, derive your various rate laws for adsorption, surface reaction, and desorption. So assuming RS, which is the rate of surface reaction, to be the rate determining step, make RA over Ka to be equal to RD over Kd to be equal to 0, since surface reaction is the rate determining step. So having made that, make CAS the subject. Everything here now is equal to 0. So make it the subject. Make CBS the CBS here the subject, since everything here is equal to 0. So that you get the value of CAS and get the value of CBS. Now put all of them back into RS. Once you put them back into RS, assume or multiply the second part of the what is inside the bracket by Ka up and Ka down, which is something as multiplying by 1. So as if you did not do anything. So that you have the expression Kb over KSKA, so that you can call it 1 over Kp. Substitute it back into the equation so that you have the final equation like as Ks KACV into bracket PA minus PB Kp. So make the site balance by saying total site is equal to vacant site plus that occupied by A and that occupied by P. Make CV the subject so that CV becomes equal to CT over 1 plus KAPA KBPB. So substitute this value in the former equation that you have, so that you have the final RS to be equal to KSKACT into bracket PA minus PB over Kp all over 1 plus KAPA plus KBPB, and that is the final rate law. So very, very important. That's how you find rate law and rate determining step. Using it to solve problems. Please copy this exactly the way I wrote it. I actually started from this place where I have A to B, and I say generate the reaction mechanism considering single site mechanism. Then write out down the rate of adsorption, rate of desorption, and derive the effective rate. So this is the mechanism, and this is the rate of adsorption, rate of the surface reaction, rate of desorption, and this is derivation of the effective rate law.